Hello everyone, today we're gonna do an example question on half-life and integrate rate law. Okay, so let's read this question. So the first sentence tells us the half-life of first order reaction is 30 minutes. Okay, so let's start to read out. So given information, half-life for this first order reaction is 30 minutes. Okay, so that's first order. And then the initial concentration of this reactant is 0.13. So the initial is 0.13 molarity, and asks you how long it takes for this the concentration goes down to 0.085. Okay, so that means at that moment the concentration of this reactant is going to be 0.085, and then how long is going to take this reaction decrease the concentration to that value. Okay, so then we're looking for time in minutes. Okay, and then when you try to solve for this question, you have to realize what you're dealing with. Okay, so you're dealing with the relationship between concentration and time, which you go, okay, I know integrity rate law is telling me a relationship between those two, and then we're dealing with the first order reaction. So now we can write out the first order reaction, the integrate rate law. So which will be ln AT equals to negative KT plus ln A naught. Okay, so then you know, okay, so one more time, this relationship, this integrate rate law telling us a linear relationship, and then between which two? Okay, so it's like this, right? So you have a linear relationship. The x is t time, y is ln the concentration, okay, at a certain time, and then we're gonna have a negative slope, and the slope is gonna be negative k, okay, because k is always what? Positive. That's rate constant, and this intercept is ln the concentration of initial. Okay, now we have this in mind, and then let's see what we know, what we don't know to solve this question. Okay, so we're looking for T. Of course, we don't know that. And then we know the final concentration. We know the initial concentration. In order to solve for T, we also need to know K. Okay, so we don't know what's the rate constant. Okay, then you go, the question didn't give me, and then let's see from the first sentence, the half-life for the first order reaction is 30 minutes. If we can get K from there, the rate constant. Okay, so now let's think about it. The half-life for first order, what's the relationship? Yeah, it's gonna be 0.693 divided by K rate constant. Okay, so remember, this is the only order among that first and second order reaction. Only the first order reaction doesn't depend on the initial concentration. Therefore, from here, we already know that half-life is 30 minutes, and then the only unknown from this relationship is going to be K rate constant. After we solve for that, we're going to put into the integrate rate law and then solve for the T. Okay, so that's the plan. Okay, so the plan is we're gonna get K first. So we're gonna get K from half-life. Okay, from the half-life for the first order reaction. Okay, so then from K we're gonna use integrate rate law because we know everything else. From here, then we can calculate T. Okay, so this is the plan. Okay, now let's go for it. Okay, so the half-life is 30 minutes equals to 0.693 divided by K. Okay, that K equals to 0.693 divided by 30 minutes. So turns out to be 0.0533 minute to -1. Okay, remember, you always need to report your unit. Okay, so that's what you have as K, and now let's put into our equation. Okay, so ln at the time we're looking for, that concentration is 0.085. Okay, so that's gonna be 0.085 equals to negative K. We just solved minute to -1 times T plus ln the initial concentration concentration is 0.13 molarity. Okay, of course, at this moment you can put a 0.085, take a natural log in your calculator, or you want to just reorganize it. So if you put the ln 0.113 onto the left side of the equation, so you have this 0.085 minus ln 0.13 equals negative 0.0533 times t. Okay, so for the operation of natural log, when you get to this point, you also know this, you can reorganize into this fashion. So you're going to have 0.085 divided by 0.13. Okay, this is something you could do, or you go, I just want to calculate the numbers. That's totally fine. You get to the same answer at the end anyway. Okay, so if you would like to do this, this value turns out to be natural log of that 0.65, 0.0533 negative times t. This value, after you put into your calculator, turns out to be negative 0.424, 0.533 minutes negative t. And then that time is going to equal to 0.424 divided by 0.0833. It's going to be 7.97 minutes. And then since, again, the question from up here, if you look at the numbers given from the question, they all have two sig figs. And then when you keep two sig figs, the answer turns out to be 80 minutes. Okay, so that's the end of this question. And then again, when you get the time, if you have a negative number, you know that's not going to be right because the time has to be positive. Okay, so this is the end of this question. Again, this question combined half-life and integral rate law. Okay, thank you for listening, and then that's it for today. Thank you.